In the earlier portion, you have learned about the Pascal's triangle. So you have already read that the definition of binomial is two terms. So we have two terms here, 1 and b. So we'll be learning about the binomial expansion of 1 plus b to the power of n. So we'll do a quick recap with the algebra method, and then we will make use of the Pascal's triangle on the expansion of 1 plus b to the power n. So just a quick one, when the power of n is 0, we already learned in sec 3 indices, anything power n is equals to 1. Now n equals to 1, you expand this, you have 1 plus b. 1 plus b square, you have learned your special algebraic identities over here. So you have 1 square plus 2 times 1 times b plus b square. And simplify it, I have 1 plus 2b plus b square. So what about 1 plus b cubed? So it's equals to 1 plus b times 1 plus b square. So let us just plug in this one, 1 plus b square, over here. We shall have 1 plus 2b plus b square. You expand this by the rainbow method. You recall rainbow method, you have this. Then subsequently, this times this times this, we will actually get 1 plus 1 plus 2b plus b square plus b plus 2b square plus b cubed. Let's simplify it at 1 plus 3b plus 3b square plus b cubed. Again, now when the power n is equal to 4, I will now bring in it is equals to 1 plus b times 1 plus b cubed. So I'll bring in this 1 plus b cubed over here. I expand by the rainbow method. This is what I'll get. Simplify it. So, don't you think it's really very tedious? Is there a more efficient method instead of doing the algebra method? And that's where you will bring in the Pascal's triangle, which you have learned earlier. And we have actually realized that as you look and compare with the Pascal's triangle, example, you can highlight this row, and over here, the algebra method, what do you notice about the numbers? Just take 10 seconds to think through. Yes, that's right. So do you notice that this 1, 4, 6, 4, and 1 is actually the coefficients over here of which one you can see this the coefficients 1. It's actually the coefficients of all the terms in the expansion of 1 plus b to the power of 4. So these coefficients are called the binomial coefficients. So let's take a look at the expansion of 1 plus b to the power n all the way up to n equals to 7. So there are some discussion questions over here. You can give it a try and we'll come to it the next lesson. But perhaps I just harp on the fifth pointer. What do you notice about the powers of b? in each row. Let's focus on one row, or let's say the last row. What do you notice? Yes, that's right. Do you notice that the power b power 1, b power 2, b power 3, b power 4? So is the numbers increasing. So the powers of b are in ascending order. So from these observations, we have learned about binomial theorem and learn about the expansion of 1 plus b to the power n.